Hi everyone. Today I'm going to show you how to implement a simple system for picking up and moving around objects in Unity, similar to how this might work in a game like Portal. Before we get started, here's a demo of how everything should look in the end. We can pick up cubes, toss them around, walk into walls and they won't go through. That's about it. So to start things off, I created a simple scene with a few obstacles and a first-person movement script for the player. So you can look around, jump, and go onto the obstacles. Next, we're going to make an object that the player can pick up. So let's just make a cube. And to distinguish this from the other objects, let's make it blue. So we'll just create a material for that and set it to blue. And now we can apply the material to this object. It's got a blue cube. Let's give it a tag that we can call pickupable, so other scripts can know that this is something that we can pick up. So we'll add a tag, call it pickupable, and then go back to the cube and apply that tag. We'll also want to give this cube a rigid body so that when we pick it up and drop it, it can interact with physics and fall back to the ground. Next, we'll need to make a script so that the player can actually pick up and move the cube around. So let's go to our scripts folder, create a new script, call it pickupObject. Then we'll drag the script onto the player. Okay, so I opened up our pickupObject script here, and let's get started. The first thing we're going to want is a field to keep track of what object we're holding, if any. So we'll call that heldObject. Next, let's set up our update function. So in terms of the general structure of our code here, we're probably going to want to do something if we have a held object and something else if we don't have one. So we can do an if held object here, and if the held object is not null, we'll do something. Otherwise, we'll do something else. So out of convenience, let's grab a reference to the player transform. And we'll also get whether we just pressed E this frame. And E will be how we pick up the cube. So if we've just pressed E and we're not holding an object, then we're going to want to figure out which objects, if any, are in front of us. So the way we'll do this is with a sphere cast. And sphere cast all will get us a list of all of the objects within the sphere that we define here. So the first part is going to be the position of the player. And we'll just want to make this be a little bit in front of the player. So we'll add the forward vector. The next thing we need is the radius of our sphere. So let's define that up here. And we'll start with something like 2. Then next, we need the direction we're going to cast in. So this will be forward again. And finally, we need the maximum distance away from the sphere. So this will be the radius as well. So now that we have a list of all the objects within the sphere, we need to find which ones, if any, have the pickupable tag on them. So let's find the first one that does. So this will be the index of the hit, and we'll use the array.findIndex function. And so this will find within hits the first hit that meets this predicate. So our predicate here will be basically checking whether the tag is equal to pickupable. So if we did find one, then hit index will not be equal to -1. And then we can get the hit object from the array. And then we'll want to set our held object to the hit object. Now we have a way to get the object that's in front of the player, but we also want to move it. So first, let's define a distance and height that it'll sit away from the player. Next, we want to set the position of the object we're holding to the player's position plus the distance and height. So let's start with the position of the held object, and we'll set that equal to first the player's position, and we want it to be the distance in front of the player, so t dot forward, and the height above the player, so height times t dot up. Now, theoretically, we should be able to pick up the object and have it float in front of us. So let's try it out. So it looks like we can pick the object up and it moves around with us. It does do some weird rotations though, and we actually can't drop it since we didn't add that in yet. So let's go fix that. To be able to drop the object, we just need to, if we're holding an object, check if we're pressing E, and then set the held object to null. So let's test that out. So we can pick it up, and now we can drop it, and it falls back to the ground. We can fix the problem where the cube rotates as we turn around by setting its rotation equal to the player's rotation. And let's test that out. So we can pick it up, and it rotates with us. Now we need to deal with two more problems. First, we can move objects straight through walls. This is because we're setting the object's transform's position directly, which completely ignores collisions. Second, after moving an object into a wall, when we let go of it, it shoots off in a random direction. This happens because when the object is inside the other object, it gets forces applied to it that don't actually take effect until we let go, because we're setting the position and rotation of the object continually. But once we let go of it, the force is finally applied. The best way to fix this problem is, instead of setting the position directly, we can add a force to the rigid body of the object. First, let's get a reference to the object's rigid body. Next, let's save the position we want to move to in a variable. Then we can get the difference between where we want to move to and where we currently are. Now let's get rid of our old movement code, and instead we'll add a force to the rigid body, and we'll multiply it by some large number, because otherwise we'll see no effect. So let's try to run the code again. Okay, so when we pick up the object here, as you can see, it's glitching all over the place. So what's happening here is when you pick up the object, it adds a force towards the position in front of the player. However, because the force is so large, it simply goes past the position and then adds another force in the previous direction. So it just keeps bouncing back and forth. To counteract this, we can add a large amount of drag to the cube when we pick it up, which will smooth out the forces that are applied to it. So let's grab the rigid body here and apply the drag to it. So we'll just apply a large amount, which will be 25 here. And another thing we need to do is turn off gravity for the cube, because otherwise the cube will continue to move downwards while it's picked up. So set use gravity to false. And then when we drop the cube, we want to do the opposite. So here we can just copy these two lines, and we'll set it back to 1, which is the default, and set use gravity back to true. Now when we run the code again, we can see that when we pick up an object, it still bounces around a little bit when we pick it up, but nowhere near as bad as it did before. And if we try to push it into a wall, it doesn't go through now. We can fix the problem where the cube bounces up and down when being picked up by moving all of the movement code into fixed update. Fixed update is meant for physics updates, which happen more than once per frame, while update only runs once per frame. This means that the force will be applied more smoothly. So let's copy all of our stuff here and move it into fixed update. And we'll need to copy this as well. And then we need to move rigid body back into here as well. Now, as a result of the additional updates, when we pick up the cube, it doesn't bounce around. It also acts a little bit less glitchily when we move things into walls. There's still one last small problem we have to fix, which is that when you move the cube into the wall and then you drop it again, it has a bit of angular velocity left from the collisions into the wall. To fix this problem, when we pick up the object, we can freeze its rotation by setting a constraint on the rigid body. And we need to do the opposite when we drop it, so we remove the constraint. Now, finally, everything works as intended. We can pick up the cube, move it into a wall, it won't go through. When we drop it, it has no angular velocity. That's it for today's video. I hope you enjoyed watching, and if you did, make sure you smash that like button, subscribe, and hit that notification bell if you want to be notified about my almost yearly uploads. I'll see you next time.